When people hear that Kafka persists every message to disk and still achieves millions of messages per second, it sounds impossible. We're taught that disk is slow, but Kafka's performance comes from the fact that it almost never performs random disk operations. At the core of Kafka is the partition. A topic is divided into partitions, and every partition is nothing more than an append-only log stored on disk. When a producer sends a message, Kafka simply appends the bytes to the end of a file. There are no updates and no in-place modifications. Sequential writes are incredibly efficient. The operating system batches them, disks prefetch data, and most writes are first absorbed by the page cache in memory. In practice, Kafka often writes at memory speed and lets the operating system flush data to disk later. Every message inside a partition receives an offset. Offsets just monotonically increasing numbers, 0, 1, 2, 3, and so on. Consumers don't delete messages after reading them. Instead, they store the last offset they processed. This means multiple consumers can read the same data independently and even replay old messages by resetting their offsets. Another important detail is that Kafka brokers don't maintain complex state about every consumer. The broker stores data, while consumers are responsible for tracking their own progress. This dramatically simplifies the broker and allows thousands of consumers to read the same topic simultaneously. When a consumer fetches data, Kafka often uses a system call called sendFile. Instead of copying bytes from disk to kernel space, then to user space, and finally back to kernel space for networking, the operating system transfers the bytes directly from the page cache to the network socket. This technique is called zero copy and drastically reduces CPU usage. Kafka also replicates partitions across multiple brokers. One broker becomes the leader for a partition and all reads and writes go through it. Followers continuously fetch data from the leader and keep their logs in sync. If the leader fails, one of the in-sync replicas becomes the new leader. The brilliance of Kafka is that none of these ideas are individually revolutionary. Append-only logs, sequential I/O, page cache, offsets, and replication have existed for decades. Kafka combines them in a way that turns disk into an advantage rather than a bottleneck, creating one of the highest throughput distributed systems ever built.